Assalamu alaikum students. In this video we will study what is Hooke's law. As you know, force is a push or a pull on an object. There are different effects of forces. Force can change direction of an object. It can make an object move if the object is at rest. Force can also change shape of an object. These are the examples of few effects of forces. In the first image to the left top, if you apply force on the spring can become longer. That is, it stretches when force is applied to it. If you apply force on a door, it changes its shape. If you apply a large amount of force on a can, it becomes dented. And if you apply force on a sponge, it squeezes. If you apply a huge force on a glass, it breaks. The force varies from material to material. If you want to make something from modeling clay, you need to apply little force. And even with this quite small force, the shape of the modeling clay can be changed and we can give a variety of shape and different things we can make from modeling clay. There are certain materials which changes shape and comes back to its original position when force is applied. A scientist, Robert Hooke, discovered the property of springs. He did a small experiment and came to know that springs change length when a force acts on them, and they return to their original length when the force is removed. This can also apply for a rubber band. If you stretch a rubber, its length increases, and as soon as you remove the force on the rubber, it comes back to its original position. The Hooke's law gives the relationship between the force applied to the spring and the amount the spring is stretched due to that force. So the actual law, Hooke's law, is the force which is applied to the spring, and this force causes the change in length of the spring. That is, there is extension in the spring. So we get the Hooke's law as force is directly proportional to the extension. That is, if force increases, the extension also increases. Springs are coiled lengths of certain types of materials, and they can be stretched or compressed by applying force to them. They are used in various different situations. They are used to absorb raised bumps in the road. If they are suspended in a bicycle, springs are also used in the chairs or cars to make sitting more comfortable. Nowadays, spring mattresses are also available. In beds, these spring mattresses are used to make sleeping comfortable. So, seeing all these properties of spring, scientist Robert Hooke did a small experiment where he took a stand and with the help of a clamp, he placed a ruler adjacent to the stand, and then a spring was attached to the end of the clamp, and slowly he started adding weight to the spring. Weight, that is force on the spring, that is mass. Now, as he was increasing the weight, the extension of the spring was also increasing, that is the length of the spring increases. So the more the mass on the spring increases, the more the spring stretches. He went on adding the weight, the load on the spring, and he noted the extension, that is the increase in the length of the spring with the help of that ruler which was attached to the clamp. And he made the readings of the increase in weight and the increase in spring. And he saw that as the weight on the spring increases, the length of the spring also increased. But this takes place only for a certain limit. When the weight is increased very much, he noticed that the spring no longer stretches, or it loses its stretching capability. So it has reached a limit after which it cannot be stretched. That limit is called as the elastic limit. So if the load is increased more, a point called the elastic limit is reached, beyond which the spring cannot increases its length. It goes back to its original length. Similarly, if you stretch a rubber band and if you apply a force to a rubber band, you can increase the length of the rubber band to a limit. After a limit, the rubber band breaks. So that point at which the rubber band breaks, that point is called as elastic limit. So it has reached its elastic limit, so it cannot be, the length of the rubber band cannot be increased more than it breaks. So this is the point called as elastic limit. So as seen, when force was increased, the extension, that is the length of the spring, also increased. The readings, if they are taken and a graph of it is plotted, the graph of force versus extension is plotted, where force is taken on y-axis, that is vertical axis, force is taken in newtons, and extension is taken in meters on the x-axis. So it was noticed that as force increases, the extension, that is the length of the spring, also increases. That means force is directly proportional to the extension. So if due to one thing, if the another increases, if one increases, the other also increases, that is called as linear graph. So if you plot the directly proportional values on a graph, you will always get a straight line. That is, you will always get a linear graph, where a linear graph shows that if one is increased, if force is increased, the extension also increases. So for the Hooke's law obeyed by the springs, the graph is a linear graph, that is, it's a straight line graph where force is directly proportional to the extension. What about a rubber band? Yes, as force is increased on the rubber band, the extension, that is the length of the rubber band, will also increase, but it will not increase in a straight manner. It will not behave same like that, like a spring. So if you try to plot a graph of force and extension on a rubber band, you will not get a straight line, but instead you will get a curve. And if you notice on this curve, there is a point where the rubber band reaches. After that point, the rubber band breaks. That point is called as the elastic limit, and that point is shown on this graph with an arrow written failure. Failure means after that if you try to stretch the rubber band, it will break. So it has reached its elastic limit. So this is the graph of Hooke's law, which shows force and extension by a rubber band. Let's see how the graph of elastic limit looks like on a spring. So if you try to plot a graph of force versus extension on a spring along with the elastic limit, so if you see the graph, initially the graph is a straight line. That means as force was increasing, the extension was also increasing. But at a point where it is marked with arrow elastic limit, at a point where spring reaches its elastic limit, the line will not be a straight line, the graph line. It will start bending, okay, or it will start decreasing. So elastic limit graph is like this as shown in the image. So Hooke's law gives the relationship between the force applied on the spring and the extension, that is the increase in length of the spring due to that force. So the statement of the Hooke's law is the force applied on the spring is directly proportional to the extension, and the graph of force versus extension is a straight line graph. That is, it's a linear graph where it shows that as force increases, extension also increases, and the point at which the length does not increase even after increasing the load, that point is called as the elastic limit. Thank you.